Our next speaker is Chad LeBeau, who is a biologist at Western Ecosystems, Inc., which is an environmental and statistical consulting firm that's been a real leader on wind energy research in the West and throughout the U.S. Chad holds a master's degree from the Ecosystem Science and Management program at UW, and he's a Howard School of Environment and Natural Resources alum, so we're really proud of him. I think it's okay if I say that. Chad has published a number of papers on wind energy and sage-grouse populations, which he'll discuss today. Thanks, Chad.
Great. Thanks for the introduction, Colin. Appreciate the invite being here, and it's great to be part of this panel. Today I'm going to talk a little bit, I'm just going to scratch the surface like Nicole said in the beginning here. Touch a little bit about sage-grouse and wind energy development. I'm first going to talk a little bit about the status of sage-grouse, then go into the potential concerns of sage-grouse and wind energy development, talk about research needs, and then finally end with some of the emerging mitigation strategies. To begin, I know a lot of you are well aware of sage-grouse. They occur in 11 U.S. states across the United States. We are experiencing range-wide population declines. And Wyoming is the stronghold. 37% of all males occur in Wyoming. And 1/4 of all sage-grouse habitat occurs in Wyoming. That's that dark green color there on the map. That's the current range of sage-grouse. Over the last few decades, it has been petitioned for listing under Endangered Species Act, and as recently as 2015. So one of the potential new threats to sage-grouse populations, similar with other forms of anthropogenic disturbance, is wind energy development. And it is a relatively new form of development that has been added to the landscape. I understand that wind energy has been around for a few decades now, but we're just starting to see it emerge in prairie grouse habitats and sage-grouse habitats across the range. However, there are a few studies that have looked at the impacts of wind energy development to sage-grouse and grouse populations. And I mentioned here there are a few studies on prairie chickens in Kansas and Nebraska, and then a Columbia sharp-tailed study in Idaho. And throughout this presentation, I'm going to refer back to those species because they are related species, and really the very few information we have is on these three species. So some of the potential concerns with wind energy development, we have the direct habitat loss, so that's the actual removal of habitat associated with access roads and turbine pads. There's the displacement, so our sage-grouse avoiding facilities or selecting habitat away from the facilities in their habitat. And does this displacement reduce overall population fitness? Is the population declining, or is it, on the converse, is it growing? And also there's a concern of reduced connectivity. Sage-grouse utilize multiple habitats through their annual cycle, and the turbine placements could disrupt the actual movement between these key habitats. And the figure on the right there is greater prairie chicken habitat selection or home range, and you can see a shift in breeding selection during the breeding period. And again, I'm going to go further into it, but this is just one example of a potential concern with sage-grouse. So to put it in perspective, this slide is to help show you the little information that we do have on grouse, and particularly sage-grouse, and the effects of wind energy development. So there's numerous publications that have been published on response of grouse and wind, but they come from forest facilities, and we only have greater prairie chicken, Columbia sharp-tailed grouse, and then greater sage-grouse here in Wyoming. So I just wanted to present this to you and show you, put a little perspective that we are talking about 4 studies from 4 different study sites across the United States. So if we follow our theme on potential over a 6-year period to identify their locations relative to turbines and different habitat features. And some of the results of that study We did detect some displacement during the brood reign in the summer period. However, we did not detect any effect during the nest site selection period, so they continued to select nest sites in and around the turbines. And we also saw no displacement during the lekking season, so the males and the females continued to use leks in close proximity to the turbines following development. And this is a similar trend that we're seeing in greater prairie chicken studies. So no effect on nest site selection in both studies that have looked at greater prairie chicken. So it's interesting to note there. Fitness. So our sage grouse being displaced, yes, we saw some displacement. How is that affecting the overall population viability or population growth rate? In our study, we found no effect on nest survival or brood survival. So we did not see any impacts of that displacement on population viability. And again, this is a similar trend to greater prairie chickens in Kansas and Nebraska. Of those long-term studies, they also found no effect on nest survival. Female survival. Female survival is one of the major contributors to population growth rate or population viability in sage grouse populations. And what we found no negative effect on female survival. We actually saw females that continue to select habitats in and around the facility had higher survival than females located further away. And again, another comparison to greater prairie chickens in Kansas. They actually saw higher survival following development of facility in Kansas. And then also in Nebraska, no effect on greater prairie chickens' female survival. And we can only speculate as to why we are seeing essentially higher survival for females located near these facilities. It could be avian predators are the main source of predation, and these avian predators, hawks, eagles, could be avoiding the facility. And this does corroborate some of our research that we looked at avian predator density relative to the facility. We did see higher density away from the facility. So here's my depiction of trying to wrap everything up. I know I presented a lot of results in a short amount of time, but it's important to understand what is going on and not provide you just with information solely on nest survival and not talk about brood survival, for example. So if you remember, females continue to select nest sites in and around the turbines, and their survival was not impacted. So once the females hatched and started raising their broods, they started shifting away from the facility. And they shifted away to avoided areas where there is higher density of turbines and access roads. And so it's different than proximities, so they continue to use habitats around the fringe of the facility, but deep in where we saw a lot of access roads and higher density of turbines, they tended to avoid. And then the females that decided to utilize habitats with higher density of turbines tended to have more or higher survival than females located further away. So this is my attempt to put it all into perspective and tell you what actually happened out there with this 6-year study. So if we jump to research needs, again, this is one of the topics that we were hoping to cover in this panel. We're going to need multiple studies across a range of sage grouse to provide some certainty on establishing disturbance buffers or anything associated or stipulations associated with wind energy development. Connectivity between key habitats. That information is lacking. We don't know if sage grouse meander through turbines between key habitats or if they fly straight through. How are they moving in and around the turbines? That's unknown at this time. And this figure just shows a connect the dots kind of figure. We need some more detailed information on that. Impacts the local populations. Again, this goes with the theme of multiple studies. One sage grouse population may be migratory, where they travel 10 kilometers between key habitats, and another population is not migratory and utilizes everything right there. The available habitat varies, so a population with a lower fragmented area may be able to sustain higher disturbance thresholds of wind energy development compared to a project that is located in higher fragmented areas where maybe there's not very much available habitat for sage grouse to move or utilize. And we also are unknown of the cumulative impacts. So I like to think of wind energy facilities as postage stamps on landscape. So we have a bunch of postage stamps spread out through the range of sage grouse, and it's unknown whether those postage stamps increases, how that's going to affect the sage grouse populations. And I imagine just as any other form of development, it is going to fragment the landscape, and the sage grouse do not do well with fragmented landscapes. They need large, intact habitats to persist. So lastly, I'm going to end on some emerging mitigation approaches. And if we follow the classic mitigation framework where we avoid, minimize, and then compensate for impacts that we could not avoid, that is the emerging theme that is through the service and through our state. And the policies are really driving the mitigation approach. So the executive order, I'm sure everyone's familiar with the state of Wyoming executive order, and then the BLM management plans that are closely related. So right now, wind energy development is not recommended in either of the core area habitats or the priority habitat management areas. And so we're really at wind energy, and the mitigation framework is really at avoidance, to limit development in core area priority habitats. However, if we look at individual frameworks and individual fragrance, we have avoidance at the landscape level, where we would cite turbines and facilities outside of sage grouse habitat, and then also the site-specific. Maybe there's some siting measures that could occur in unsuitable habitat or already disturbed areas. There are also some minimization measures that can be in place that are being utilized in facilities that are being constructed in sage grouse range. Construction timing stipulations, limiting disturbance during the breeding period, and also limiting the disturbance thresholds on the landscape. Again, this is getting back at that fragmentation. We want to reduce fragmentation to sage grouse habitat. Like buffers, we may be siting outside of state recommended or agency recommended like buffers to reduce the impacts. And then also habitat assessments. We may go out and evaluate habitat and site turbines in lower quality habitat or habitat that may not be as useful to the population. And so compensatory mitigation. This is the part where Wyoming and wind energy development is not that I'm aware of. So we're at the avoidance level if we remember that there's no mechanisms to drive that compensatory mitigation as the core area and the priority habitats. But if we were to go that route, and if a wind energy development would like to mitigate outside of core area, we would first want to estimate the impacts, the debits, and then offset those impacts by accruing credits. And the state of Wyoming just recently published or finalized their mitigation framework, which provides avenues for mitigation and debit calculations. And so we can purchase credits to offset these impacts on the Wyoming mitigation framework through habitat conservation banks or habitat exchanges and other mechanisms that meet the definition of the state's credit. So with that, bringing it full circle, there is very little information specific to sage grouse. We can draw similarities to other prairie grouse species that are related to grouse. They evolved into grassland habitats. But overall, there's pretty low inference on the overall impacts across the sage grouse range. However, based on best available science, and again, this is from the one study here in Wyoming, we did detect some displacement, but the displacement did not result in overall population, a reduction in overall population viability. And we are seeing that trend in other grouse populations too across the United States. And so I think that is an interesting trend that we are seeing starting to emerge. And again, I've reiterated this enough in multiple studies across the range. Each population may be different than another. And then state and federal policies are really driving the mitigation framework relative to wind, and those are the mechanisms for actually implementing the mitigation measures. So with that, I would happy to answer any questions you might have.
Thanks, Chad. That was a great presentation. How many years did your study, the one that you presented there, take place over? And I know that other studies have shown a lag effect in population over time, so I'm curious if you thought about that and if you feel like you've enough time has gone by that you can be sure that your results really do indeed show no impacts on population viability.
Sure. Yeah, so our study was a 6-year study, and over that time period, we did consider time lag. So sage grouse, as new juveniles are recruited to the population, they may alter their habitat selection or their survival parameters. We did detect a time lag effect during the brood rearing period. So we saw a higher magnitude of avoidance 3 years following development than the first 2 years, and so we did detect a lag effect. And each one of our analysis estimated or investigated lag effects. And so we're confident that if impact existed, we would have detected over that 6-year period. And also in our lag study, we did have 8 years post-construction research and then 3 years pre-development. So over that same time period, males continue to use the same lags, and we're confident that if we would have saw a reduction in male count, we would have saw a reduction in our survival in our juveniles recruited to that population during that same time period. So it's interesting that both of those analyses corroborated each other pretty nicely.
Chad, thank you also for your presentation. I was curious if you did any look at the impacts of transmission lines and active roads on the viability of these birds. I've seen studies in the prairies on what's taking place with the sharpies and the prairie chickens, and there's an impact. And then secondly, is there any effort to take a look at what's happening to our sharpies on the east edge of the state, east of Laramie's policy is to move our wind over there? And we know it's going to be an impact. Doesn't seem to be much going on. Thank you.
Yeah, so there's quite a bit of research out there on impacts of roads, and there's quite a bit of literature on transmission lines. We certainly are looking at that in our study right now, working on some manuscripts now, but during our study, we incorporated transmission lines and roads to make sure that those anthropogenic features were not confounding our effect of the facility. And so we did take that into account and make sure that we did evaluate that. As far as the sharpies in the western part of the state, I understand there is some research going on investigating that population. As far as relative to wind years development, I'm not familiar with anything going on out there. I know they are monitoring that population though. And that's here at the university.
Interesting study. I was curious what your annual mortality rate was on the sage grouse hens on the 7 Mile project, and whether that had any bearing on your conclusions.
Yeah, so annual mortality, I can't recall the actual number offhand, but it was lower than females that were located further out. And so I don't have much time to go into a lot more detail to show you a study map and stuff like that, but we did have individuals monitored 15 kilometers from the facility, and so that's where we were making the comparison to. We did have a control and treatment study design, but I apologize, I don't have the actual female survival.
What was the difference in survival as compared to, I assume there was no hunting in the area of the turbines, and there was hunting further away. Would that be a possibility?
Well, actually, hunting did occur across both study areas. Familiar with the landowner out there, and does allow hunting to occur at both study sites, and so I don't think it's enough to influence the overall survival rates. I think we had 2 of our birds harvested over the 6-year period, so I don't think it was a large enough driver to affect the survival rates between the 2 study areas.
Hey Chad, thanks. In your list of mitigation options, I didn't see habitat restoration or improvement in there. Do you think that, what are your thoughts on improving the habitat within and around the wind projects? Do you you think that would have a benefit, or is the displacement effect too big that you wouldn't see a benefit?
Yeah, and that's a different mitigation strategy, restoration versus preservation. I imagine, obviously, we would want our habitat to be restored and be used. So if there was an opportunity to enhance the habitat, I would imagine that that would be best. Whether they come back and use that habitat, I'm not sure that would ever occur. As I understand wind facilities, they have a direct disturbance which is associated with the access road, and then some other areas where they may enhance or revegetate. I don't anticipate that those habitats would be reused following development due to the revegetation and the actual presence of the turbines.
Thanks, Ted.